the 14th of October 1943, somewhere near Aachen, Germany, the unmistakable silhouette of a damaged P-47 Thunderbolt descended through broken cloud cover, its massive R-2800 Double Wasp engine trailing a plume of black smoke. Lieutenant Emily Sullivan of the 56th Fighter Group, 8th Air Force, had lost control of her aircraft during a fierce dogfight above the industrial heartland of the Reich. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. Her fighter, bearing the squadron code UNS and nicknamed Wicked Witch, struck the German countryside with surprising gentleness, skidding across a recently harvested field before coming to rest against a small copse of trees. Sullivan survived the crash landing with minor injuries and would spend the remainder of the war as a prisoner at Stalag Luft III, but her aircraft, serial number 42-7-5044, a P-47D-5RE model, was about to embark on a journey that would profoundly shake the assumptions held by some of the Luftwaffe's most experienced armament specialists and test pilots. The Thunderbolt lay relatively intact in that German field, soon to be recovered by German salvage teams who had developed systematic protocols for retrieving crashed Allied aircraft across the Reich and occupied territories. Within weeks, this particular machine would be transported to Reich, the Luftwaffe's primary testing facility, located approximately 100 kilometers northwest of Berlin in Mecklenburg, where it would undergo repairs using components salvaged from other less repairable wrecks scattered across German-controlled territory. The aircraft would emerge wearing German markings, its fuselage bearing the Luftwaffe code T9+GK, its tail and undersides painted in bright RLM4 yellow for easy identification by German pilots who might otherwise mistake it for an enemy aircraft during flight operations. The propeller spinner received yellow paint and a distinctive red band adorned the nose, signifying its status as a captured enemy aircraft. Following standard Luftwaffe procedures for captured aircraft, this Thunderbolt was destined for service with one of the Luftwaffe's most specialized units, the Wanderzirkus Rosarius, where it would force German fighter pilots to confront an uncomfortable reality about American firepower, industrial capabilities, and their own increasingly untenable tactical situation in the deteriorating air war over Europe. The story of how captured enemy aircraft became instruments of revelation for the Luftwaffe begins not with Sullivan's forced landing, but with the escalating air war over Europe and the desperate need for accurate intelligence about Allied aircraft capabilities that went beyond the fragmentary combat reports received from frontline pilots. By mid-1943, the Luftwaffe faced a strategic crisis that threatened to overwhelm German air defenses, despite the considerable skill of individual pilots and the ongoing development of advanced aircraft designs. American bomber formations were penetrating deeper into the Reich with each passing month, protected by fighters whose true capabilities remained partially mysterious to German commanders who had to make tactical and strategic decisions based on incomplete information. Intelligence reports from combat pilots provided fragmentary accounts of enemy aircraft performance, but these reports often conflicted with one another and reflected the chaos and confusion of aerial combat rather than systematic analysis under controlled conditions. What was particularly confounding to German commanders was the devastating effect of the P-47's armament on Luftwaffe fighters, with pilots returning with tales of brief bursts from Thunderbolts that shredded their aircraft beyond recognition. Hauptmann Theodor Rosarius, an experienced Luftwaffe officer, understood that German fighter units needed more than scattered combat reports and second-hand accounts to counter the Allied threat effectively. They required hands-on experience with captured enemy aircraft, structured opportunities to examine these machines under controlled conditions, and systematic evaluation to discover their strengths and vulnerabilities through direct testing and analysis. The concept was not new. Both the Allies and Germans had tested captured aircraft throughout the war, but Rosarius would organize and systematize the approach in ways that maximized its tactical value. In 1943, following orders from General der Jagdflieger Adolf Galland, Rosarius formed what would become known as the Wanderzirkus Rosarius, officially designated as Kommando Rosarius of the Versuchsverband des Oberbefehlshabers der Luftwaffe, the Trials and Research Unit of the Luftwaffe High Command. This specialized unit received all repairable captured Allied aircraft that German salvage teams recovered from crash sites across occupied Europe, from France to Italy to the Eastern Front. The unit's mission extended well beyond simple static testing at secure facilities behind the lines. Rosarius organized traveling demonstrations where captured aircraft would visit operational Luftwaffe fighter bases across Germany and occupied territories, allowing frontline pilots to examine these machines up close, observe them in flight, and participate in detailed technical briefings about their capabilities. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now back to the story. The recovery operation for Allied aircraft had become highly systematized by 1943, with specialized German salvage units operating across occupied territories under the direction of Bergebataillon, or salvage battalions. These teams worked with remarkable efficiency to secure crash sites, assess damage, and transport repairable aircraft to centralized testing and repair facilities, before advancing Allied forces could recapture the wreckage. The organizational structure reflected German military thoroughness, even as resources grew scarcer. The scale of Allied air operations over Europe made captures inevitable through sheer statistical probability. With thousands of sorties flown monthly by American and British forces, mechanical failures, battle damage, navigation errors, fuel exhaustion, and weather-related incidents resulted in numerous forced landings on German-controlled territory. Not all of these aircraft were destroyed on impact or rendered irreparable by crash damage. Some pilots, recognizing their situation was hopeless, executed controlled crash landings that left their machines largely intact, sometimes even with minimal structural damage that could be repaired with available resources and components. Sullivan's P-47D-5RE fell into this category of repairable captures. The aircraft had sustained damage during intense fighter sweeps, supporting bombing raids over western Germany, forcing an emergency landing in territory that remained firmly under German control despite the increasing Allied air presence. German recovery teams reached the site within hours, following established procedures for evaluating crash sites. They examined the Thunderbolt carefully, assessed the extent of damage, and determined that despite battle damage and crash impact, the airframe remained sufficiently intact for repair and restoration to flight-worthy condition. The aircraft was carefully loaded onto a specialized transport and sent to Reich, where experienced technicians and engineers worked systematically to restore it to flying condition. Reich Testing Center, formerly known as Erprobungsstelle Reich and located near Lake Müritz, served as the Luftwaffe's primary facility for evaluating new German aircraft designs and conducting detailed testing of captured enemy types. The facility, which had been officially designated the Luftwaffe's Central Testing Facility on the 26th of February 1936, included extensive workshops equipped with specialized tools, comprehensive test ranges for various evaluation protocols, and runways specifically configured for evaluation flights under controlled conditions. Technicians at Reich possessed considerable skill in reverse engineering and repairing Allied aircraft, despite lacking original technical manuals, factory specifications, and genuine spare parts manufactured to original tolerances. The repair process for Sullivan's Thunderbolt required substantial ingenuity and resourcefulness that spoke to both German technical competence and the increasing challenges of working with limited resources. Technicians cannibalized components from other crashed P-47 seconds recovered across Europe, building an inventory of parts that could be matched and fitted to create one flight-worthy aircraft from multiple damaged machines. The massive Pratt & Whitney R-2800 Double Wasp engine, an 18-cylinder air-cooled radial that produced 2,000 horsepower, underwent detailed inspection and necessary repairs using replacement parts obtained from multiple sources. This engine represented significant technological achievement, delivering substantially more power than any German radial engine in operational service through its two-row design and sophisticated supercharger system. What particularly interested German engineers was the Thunderbolt's formidable armament, 8 50-caliber Browning M, 2 machine guns mounted in the wings, 4 per side, capable of delivering a devastating 13 pounds of lead per second when fired simultaneously. This firepower exceeded anything mounted on German fighters, which typically carried a mix of 7.92mm machine guns and 20mm cannons in much smaller numbers. For test purposes, the aircraft's 50 caliber Browning M2 machine guns were removed and replaced with ballast weights to maintain proper weight distribution and center of gravity, as German regulations strictly prohibited arming captured aircraft used for testing and demonstration purposes. This restriction reflected both safety considerations and concerns about captured aircraft potentially being used against German forces if they fell back into Allied hands through mishap or defection. However, the guns themselves became the subject of intense scrutiny by German weapons specialists, who evaluated their construction, feeding mechanisms, reliability features, and theoretical firepower calculations compared to standard German fighter armament. What they discovered was deeply concerning. The American 50 caliber weapon combined exceptional reliability, excellent ballistic properties, and overwhelming volume of fire that German fighters with their mixed armament simply could not match. Control surfaces were thoroughly examined for structural integrity and proper operation. Hydraulic systems underwent pressure testing and inspection for leaks. Fuel tanks were carefully inspected for damage, cracks, and potential leak points that could cause catastrophic failure during flight operations. The distinctive razorback canopy design that characterized early P-47 models was carefully preserved and repaired, though German pilots would later note how the framed canopy restricted rearward visibility compared to the bubble canopy introduced on later variants. After weeks of meticulous work by skilled technicians working with limited resources and improvised solutions, the Thunderbolt was declared ready for initial test flights. German test pilots approached their first encounters with the captured American fighter with professional curiosity mixed with considerable skepticism born from years of Luftwaffe propaganda. Official information had consistently portrayed American aircraft as crude, mass-produced machines that prioritized quantity over quality, emphasizing manufacturing ease and simplicity rather than sophisticated engineering and refined performance. The prevailing view among many German pilots, reinforced by official communications, held that American engineering focused on producing adequate numbers of acceptable aircraft rather than pursuing the engineering excellence and performance optimization that characterized the best German designs. These comfortable assumptions began dissolving rapidly the moment experienced German test pilots climbed into the Thunderbolt's cockpit and experienced firsthand what American designers and engineers had actually achieved through careful design, sophisticated engineering, and meticulous attention to operational requirements. The cockpit layout of the P-47D immediately impressed German pilots familiar with the cramped confines of Messerschmitt Bf. 109 cockpits, and even the more spacious accommodations of Focke-Wulf FDW 192. The Thunderbolt cockpit demonstrated thoughtful ergonomic design, with controls logically arranged and positioned within easy reach, reducing pilot workload and allowing concentration on tactical situations rather than struggling with aircraft systems. Instruments were clearly marked with easily readable gauges and sensibly grouped by function, following human factors, principles that prioritized pilot effectiveness. The seat provided noticeably better comfort than German fighters, an important consideration during multi-hour missions where pilot fatigue could significantly impact performance and decision-making. Visibility, even in the earlier Razorback configuration with its framed canopy, exceeded what Bf 109 pilots experienced with their heavily framed canopies, restricted sight lines, and particularly poor rearward visibility that left German pilots vulnerable to attacks from behind. But the true revelation came when German test pilots advanced the throttle and felt the massive R-2800 Double Wasp engine respond with tremendous power. The Thunderbolt accelerated down Recklin's runway with surprising authority, despite its considerable size and weight, the four-bladed Curtiss electric propeller converting the engine's 2,000 horsepower into effective thrust with remarkable efficiency. Once airborne, the Thunderbolt revealed handling characteristics that fundamentally challenged everything German pilots thought they understood about American aircraft design, philosophy, and engineering capabilities. Though noticeably heavier than the nimble German fighters, the P-47 displayed well-harmonized control responses and predictable behavior throughout its flight envelope. Flight controls were surprisingly well balanced, with aileron, elevator, and rudder forces properly coordinated across the entire speed range. Control forces increased predictably with speed, providing good feedback without becoming excessively heavy, and decreased smoothly at lower speeds without becoming overly sensitive. The Thunderbolt responded crisply to control inputs despite its size, demonstrating a level of refinement that German pilots had not expected from American designs. German test pilots systematically evaluated the Thunderbolt's performance envelope through carefully planned test flights, pushing the aircraft through standardized maneuvers specifically designed to reveal its strengths, limitations, and any hidden dangerous characteristics. Climb performance, while not spectacular, proved solid and consistent, with the powerful R-2800 engine maintaining good power output at altitudes where many engines began to struggle. What most impressed German evaluators, however, wasn't the Thunderbolt's flight performance, which they deemed good but not revolutionary. What shocked them was the implications of its armament system when they conducted detailed technical evaluations of the 8.50 caliber Browning machine guns. The German armament experts calculated that the P-47's gun battery could deliver approximately 13 pounds of ammunition per second when all 8 guns fired simultaneously. This represented a volume of fire that far exceeded anything mounted on standard German fighters. The standard armament of a Messerschmitt Bf 109G typically consisted of one 20mm cannon firing through the propeller hub and two 13mm machine guns mounted on the engine cowling, delivering approximately 4.4 pounds of ammunition per second. The Focke-Wulf 190A, with its heavier armament of two 13mm machine guns and four 20mm cannons, could deliver approximately 7.5 pounds of ammunition per second. Even this, German specialists calculated, fell substantially short of the Thunderbolt's devastating firepower. Moreover, the placement of the P-47's guns in the wings allowed them to be mounted rigidly without the complexity and reliability issues associated with synchronization gear required for weapons firing through the propeller arc. The German specialists were particularly impressed with the 50 caliber Browning's remarkable reliability under combat conditions. Their evaluation of recovered guns showed robust construction, excellent machining quality, and design features specifically engineered to prevent jams and stoppages during high-G maneuvers and extended firing sequences. The ammunition belt feeding system demonstrated particularly thoughtful design, with features that minimized the risk of belt breakage or misfeeds, even during violent aerobatic maneuvers. German armament experts determined that while their 20mm cannons theoretically delivered more destructive power per hit, the P-47's overwhelming volume of fire, exceptional reliability, and the excellent ballistic properties of the 50 caliber round more than compensated for the smaller individual projectile size. The probability of scoring multiple hits on a target aircraft during a brief firing opportunity was substantially higher with the Thunderbolt's 8-gun battery than with the mixed armament of German fighters. This realization proved particularly concerning because German aircraft generally lacked the armor protection necessary to withstand concentrated 50 caliber fire. German fighters were designed with protection primarily against 7.7mm and 12.7mm projectiles fired from typical Allied fighter armament, but the concentration of 8 heavy machine guns firing simultaneously created a density of fire that could overcome these protections through sheer volume. Speed trials conducted under controlled conditions at various altitudes confirmed the Thunderbolt's impressive maximum velocity. The P-47D could achieve approximately 428 miles per hour at optimal altitude, with the engine running at military power settings, significantly faster than the Messerschmitt Bf 109Gs, approximately 386 miles per hour, and comparable to the Focke-Wulf FW 190A's approximately 408 miles per hour when measured under comparable conditions. This substantial speed capability, combined with the aircraft's considerable weight and robust construction, gave it exceptional diving performance. German test pilots discovered that the Thunderbolt could outdive virtually any German fighter, accelerating rapidly in a steep dive and reaching speeds where control surfaces on many fighters began to lose effectiveness. Yet the P-47's controls remained responsive even at these extreme speeds, allowing pilots to pull out of dives with precision rather than fighting stiffened or locked controls. Dive testing revealed a particular area where the Thunderbolt excelled beyond anything in the German inventory. When placed in a steep dive, the P-47's considerable weight, nearly 10,000 pounds empty compared to the Bf-109G's approximately 6,000 pounds, combined with its robust airframe and powerful engine, allowed it to accelerate to speeds approaching 550 miles per hour. At these velocities, the Thunderbolt's controls remained effective, while German fighters often experienced severe control stiffening or complete loss of elevator authority that could prevent recovery from steep dives. German test pilots noted this capability with particular concern because it eliminated a key tactical advantage German fighters had enjoyed over earlier Allied types. When confronted with superior numbers or unfavorable tactical situations, German pilots had often employed steep diving escapes, counting on their ability to pull away from pursuing Allied fighters whose controls became ineffective at high speeds. The Thunderbolt's exceptional dive performance and control effectiveness at extreme speeds closed this escape route, forcing German pilots to find alternative defensive tactics. Turn performance presented a more complex picture. The Thunderbolt could not match the sustained turn rate of the Bf-109 level turning engagements at moderate speeds, particularly as the Bf-109 benefited from leading-edge slats that automatically deployed during high angle of attack maneuvering and delayed wing stall during tight turns. In sustained slow-speed turning fights at medium altitudes, the lighter and more compact Bf-109 held a measurable advantage in turn radius and turn rate. However, German pilots discovered through systematic testing that the Thunderbolt's clear superiority in energy retention and dive performance allowed skilled pilots to avoid sustained turning engagements entirely and instead fight using energy tactics. The P-47 excelled at converting speed to altitude and altitude back to speed efficiently, enabling pilots to maintain energy state throughout combat maneuvering. This capability allowed Thunderbolt pilots to dictate engagement terms, choosing when to attack and when to extend away from combat. The Thunderbolt's structural strength and robust construction impressed German engineers who examined the airframe in systematic detail at both Rechlin and at Göttingen, where more detailed technical evaluations occurred. The aircraft was substantially overbuilt, with significant safety margins engineered into critical structural components throughout the airframe. This robust construction philosophy contrasted markedly with German design approaches that often pushed structural limits to absolute minimums in pursuit of weight reduction and maximum performance. The P-47 could sustain significant battle damage that would have destroyed lighter German aircraft and still successfully return to base, a capability that directly translated into pilot survival rates and aircraft availability for subsequent missions. American engineering philosophy clearly emphasized survivability and maintainability, accepting somewhat higher empty weight in exchange for durability that kept aircraft and pilots in combat longer. But it was the armament system that generated the most serious concerns among German evaluators. Beyond the sheer volume of fire delivered by 8 50 caliber machine guns, detailed examination of the weapons themselves revealed sophistication that contradicted German assumptions about American industrial capabilities. The Browning M2 50 caliber machine guns were manufactured to extremely tight tolerances with excellent quality control, featuring heat-treated components that maintained reliability even during extended firing sequences. The guns were mounted in the P-47's wings, in a staggered arrangement that both distributed weight effectively and ensured optimal convergence of fire at combat ranges. The installation included sophisticated harmonization adjustment mechanisms that allowed armorers to precisely align all 8 weapons to converge at a specific distance, creating a concentrated pattern of fire that maximized hit probability during brief firing opportunities. Ammunition feed systems demonstrated equally thoughtful design. The disintegrating metallic belt links used with the 50 caliber ammunition represented a sophisticated solution to feed reliability problems, allowing smooth operation during high-G maneuvers, while eliminating the weight and reliability issues associated with continuous belt systems. The ammunition itself featured meticulously constructed cartridge cases with consistent powder charges and precisely manufactured projectiles that ensured excellent ballistic consistency. These discoveries forced uncomfortable reassessment of German assumptions about American manufacturing capabilities and engineering sophistication. Far from being crude or simplistic, the Thunderbolt's weapons system represented highly refined engineering, sophisticated manufacturing processes, and careful attention to reliability under combat conditions, areas where late-war German weapons increasingly struggled due to material shortages and production compromises. The Wanda Circus Rosarius took the captured and repaired Thunderbolt-coded T9 plus GK on an extensive tour to operational Luftwaffe fighter bases across Germany during mid-1944, visiting numerous locations where frontline fighter units were based. At each stop, the unit would establish temporary operations and set up comprehensive demonstrations, showing German pilots exactly what Allied aircraft could do in flight, and teaching them specific tactics designed to counter Allied strengths, while identifying and exploiting whatever weaknesses could be found. The demonstrations typically began with captured aircraft taxiing past assembled German pilots and ground personnel, creating surreal scenes as enemy aircraft bearing German markings and bright yellow identification paint moved among German fighters. Seeing these aircraft up close had substantial psychological impact, making the enemy tangible and real rather than abstract. Then came flight demonstrations where experienced German test pilots would fly the captured aircraft through carefully choreographed aerobatic routines and tactical maneuvers, demonstrating specific performance capabilities in ways that were far more effective than written reports or verbal briefings could ever be. For the Thunderbolt demonstrations, test pilots would perform high-speed passes at low altitude to dramatically show the aircraft's speed and diving capabilities. They would execute rolling maneuvers to display the P-47's excellent roll rate despite its size. They would demonstrate the remarkable structural strength by performing high-G pullouts from steep dives that would stress lighter airframes to their limits. Mock dogfights against German fighters would illustrate both the Thunderbolt's strengths and the limited circumstances under which German fighters retained advantages. After the flying display concluded, pilots and ground personnel could approach the aircraft on the ground, examine it closely, inspect the cockpit layout and instrument panel, and ask detailed questions of the test pilots who had extensive experience flying the captured machine. These hands-on educational sessions proved invaluable for demystifying enemy aircraft and providing concrete, tangible understanding of what German pilots faced in actual combat operations. One particularly revealing component of these base visits involved detailed technical briefings on the P-47's armament system. German ordnance specialists who had thoroughly examined the Thunderbolt's 8 50 caliber machine guns would provide comprehensive presentations on their findings, comparing American and German fighter armament with sobering precision. During one such briefing at a fighter base in central Germany, the German armament specialist presented detailed technical information that generated serious concern among the assembled pilots. Using comparative firing rate calculations, hit probability assessments, and armor penetration data, he methodically demonstrated how the Thunderbolt's 8-gun battery represented a fundamental threat to German aircraft that exceeded anything they had previously encountered. The reality we must confront, the specialist explained while displaying comparative charts, is that our standard fighter armament philosophy focused on mixed installations combining machine guns with cannon is based on the assumption that a small number of cannon hits will ensure destruction of the target aircraft. This remains valid. A direct hit from a 20mm or 30mm shell will indeed cause catastrophic damage. However, this approach requires precision accuracy under combat conditions. The American approach with the P-47 fundamentally changes the equation by prioritizing overwhelming volume of fire rather than individual projectile destructive power. Their 8.50 caliber guns create a dense pattern of fire that virtually ensures multiple hits during even the briefest firing opportunity. Our testing indicates that while a single 50 caliber round may not match the destructive power of our cannon shells, the cumulative effect of multiple hits, which is virtually guaranteed with this weapon system, more than compensates for the smaller individual projectile size. The presentation included high-speed camera footage showing the effect of concentrated 50 caliber fire on aircraft structures, demonstrating how multiple hits occurring within fractions of a second could shatter structural components, destroy control systems, and penetrate fuel tanks almost as effectively as cannon shells, but with substantially higher hit probability. The most sobering information came from his comparative assessment of German protective systems against this threat. Our current aircraft armor protection is designed primarily to shield vital components and crew against isolated hits from various caliber projectiles. However, it cannot withstand the concentrated pattern of multiple simultaneous 50 caliber hits that the P-47's armament delivers. The sheer volume of fire effectively overwhelms our protective systems. When a pilot asked about the relative merits of German cannon versus American machine guns, the specialist provided a blunt assessment that contradicted years of Luftwaffe doctrine. Our cannon undoubtedly deliver superior destructive effect per individual hit. However, combat effectiveness ultimately depends on the ability to achieve hits on target under actual combat conditions. Our analysis of combat gun camera footage and recovered aircraft shows that the P-47's 8-gun battery compensates for the lower individual destructive power through vastly superior hit probability. Their approach represents a fundamentally different philosophy, ensuring hits through volume of fire rather than maximizing damage from the limited number of hits our system typically achieves. This assessment generated a considerable discussion among pilots who had been trained to value the destructive power of cannon over machine guns, and who had developed tactics based on making brief, accurate firing passes against enemy aircraft. The realization that American fighters could achieve significantly higher hit probabilities through concentrated machine gun fire challenged fundamental assumptions about optimal fighter armament and tactical approaches. The most valuable and impactful component of these base visits involved mock combat sessions where captured Allied fighters would engage German fighters in carefully controlled, simulated combat under observation. Selected, experienced German pilots would fly their own operational aircraft against the captured types, experiencing firsthand how Allied fighters handled in dynamic combat situations and learning what worked and what proved ineffective against specific Allied aircraft. One such demonstration took place at an airfield hosting Jagdgeschwader 3 during mid-1944 as Allied bomber operations intensified and German losses mounted. The base commander had arranged for several of his most experienced pilots to fly mock engagements against the captured Thunderbolt to gain practical knowledge they could pass on to squadron mates. The German test pilot flying the P-47 demonstrated tactics that American pilots typically employed in actual combat, using the Thunderbolt's advantages in diving performance and energy retention while avoiding situations where its weight and size became significant. Disadvantages: German pilots flying Messerschmitt Bf 109Gs and Focke-Wulf FW 190 as attempted to engage the Thunderbolt using standard Luftwaffe tactics that had proven effective against earlier Allied fighters. What became immediately apparent during these mock combat sessions was the difficulty German pilots faced in achieving and maintaining firing position against a Thunderbolt piloted by someone who understood its performance envelope. When German fighters attempted to press attacks from behind, the P-47 could simply enter a steep dive, accelerating away at speeds German aircraft could not safely match. When German pilots tried to set up diving attacks from higher altitude, the Thunderbolt's roll rate and robust control authority allowed it to break the attack with well-timed defensive maneuvers, then counter with its own diving attack as the German fighter extended away. Most concerning to the German pilots was the realization that even brief exposure to the Thunderbolt's formidable armament could prove fatal. During the tactical briefings that followed these mock combat sessions, The Wanda Zirkus Rosarius team presented gun camera footage showing actual combat engagements where German fighters disintegrated under concentrated fire from P-47 seconds, often after exposure times of less than 1 second. The mock-up demonstration included simulated firing passes with illuminated aiming points to show precisely how the pattern of 8 50 caliber guns would saturate a target aircraft. This concrete visualization of the Thunderbolt's firepower had profound psychological impact on pilots who suddenly understood in visceral terms why so many of their comrades had failed to return from encounters with these American fighters. This pattern of revelation and gradually dawning realization repeated itself across numerous Luftwaffe bases, where the Wanda Zirkus Rosarius conducted demonstrations throughout 1944. German pilots received official assurances about the continuing superiority or at least competitive parity of their aircraft during pre-demonstration briefings, then experienced actual combat and flight demonstrations that directly contradicted those optimistic assessments. The captured aircraft demonstrations provided concrete, undeniable evidence that German fighters faced formidable opponents whose capabilities significantly exceeded what propaganda and official communications suggested. Walter Dahl, who commanded fighter units during 1944, later wrote about Wanda Zirkus Rosarius' visits to his bases in his memoir, though historians note his accounts must be treated cautiously due to documented reliability issues throughout his writing. He described how captured American fighters would arrive, along with captured bombers, creating unusual and somewhat surreal scenes where enemy aircraft parked peacefully alongside German machines while pilots examined them closely. Formation leaders received opportunities to fly captured aircraft in controlled mock combat, allowing them to understand Allied aircraft characteristics through direct personal experience rather than relying solely on second-hand reports and official briefings. Dahl emphasized the substantial value of this training, noting that familiarity with enemy aircraft capabilities represented a critical factor in aerial combat, where split-second decisions often determined survival. Following these demonstration sessions, flight leaders would conduct detailed training lectures with their squadron members, passing along specific recommendations and tactical insights based on their personal observations and direct experience with captured Allied aircraft. This systematic knowledge transfer helped prepare German pilots for combat encounters with more realistic understanding of both Allied strengths and the increasingly limited circumstances under which German fighters retained exploitable advantages. The program achieved decidedly mixed results by late 1944, as Germany's strategic situation deteriorated across all fronts. While the demonstrations unquestionably provided valuable tactical intelligence and improved German pilot understanding of Allied aircraft capabilities, this knowledge could not overcome the fundamental and growing disadvantages German forces faced. The Luftwaffe suffered from chronic and worsening fuel shortages that severely limited flight training hours for new pilots, resulting in inadequately prepared pilots being sent into combat with minimal experience. Experienced pilots, who understood through hard-won combat experience how to fight effectively against aircraft like the P-47, were increasingly rare, lost to relentless attrition during the brutal air combat of 1944 that saw German fighter pilot losses reach unsustainable levels. Aircraft production, while remaining surprisingly high despite intensive Allied strategic bombing of German industry, could not replace losses quickly enough to maintain force strength. Most critically, the training revelations from captured aircraft often served primarily to demoralize rather than inspire, as pilots realized the full extent of their disadvantages. German pilots recognized with growing clarity that they flew aircraft that could not match the combined advantages of American fighters in the most critical performance categories for the missions they were assigned. The Thunderbolt's devastating armament, exceptional diving performance, and robust construction could not be matched by any available German fighters in operational service. The technical intelligence gathered from captured P-47 seconds extended well beyond simple flight testing and combat evaluation. German engineers at both Rechlin and Göttingen systematically disassembled components to understand American manufacturing techniques, material selections, and detailed design approaches. They examined the wing structure and airfoil sections in meticulous detail, studying the construction methods and attempting to understand precisely how American designers had achieved such robust performance while maintaining acceptable handling characteristics despite the aircraft's considerable size and weight. They analyzed the Pratt & Whitney R-2800 Double Wasp engine with great interest, noting its sophisticated two-row radial design that delivered exceptional power output and reliability compared to German radial engines. The armament system received particularly detailed attention as ordnance specialists attempted to understand how American designers had created such a formidable weapons package that combined extraordinary volume of fire with exceptional reliability under combat conditions. German engineers noted repeatedly the consistently high quality of materials used throughout the aircraft. American access to strategic materials like high-grade aluminum alloys, specialized steels, and reliable rubber compounds allowed designers to create structures that effectively combined strength with acceptable weight while maintaining production efficiency. Germany faced increasingly severe material shortages by 1944, forcing the use of substitute materials that often proved inferior in strength, durability, or manufacturing characteristics. The investigation of captured Thunderbolts revealed sophisticated manufacturing techniques that enabled true mass production without significantly compromising quality standards. American factories produced P-47 seconds using highly developed assembly line methods that maintained remarkably tight tolerances and consistent quality across thousands of individual aircraft. German production had become increasingly reliant on dispersed manufacturing in smaller facilities, scattered across the country to avoid concentrated bombing, sometimes using inadequately trained forced labor, resulting in inconsistent quality, reduced production efficiency, and increasing maintenance problems with operational aircraft. The captured Thunderbolt, designated T9 plus GK, served with Wanderzirkus Rosarius until the 14th of February 1945, when the aircraft was destroyed during an Allied bombing raid on the airfield where it was stationed. By that point in its second operational life, the aircraft had traveled extensively across Germany, visiting numerous Luftwaffe bases and providing direct hands-on education to hundreds of German pilots, who gained invaluable first-hand knowledge of American aircraft capabilities. Other captured P-47 seconds served similar evaluation and demonstration roles for the Luftwaffe. German records and post-war research indicate that at least 3 Thunderbolts definitely operated with the Wanderzirkus Rosarius at various times during 1943 to 1945, bearing the Luftwaffe codes T9 plus GK, T9 plus BK, and T9 plus LK. Each represented different variants of the Thunderbolt, allowing German evaluators to trace the development of the type and assess improvements incorporated in successive production blocks. The T9 designation code was not officially assigned to any existing Luftwaffe operational formation in German organizational records, strongly suggesting it represented an ad hoc code used specifically for Wanderzirkus. Rosarius captured aircraft operations rather than following standard Luftwaffe organizational structure. The broader implications of German pilots directly experiencing and thoroughly understanding the P-47's formidable firepower extended well beyond immediate tactical considerations. The Thunderbolt's 8.50 caliber machine guns represented tangible, undeniable evidence that American industrial and engineering capabilities equaled or exceeded German achievements in critical areas, contradicting years of propaganda about American industrial and technical inferiority. This uncomfortable realization challenged fundamental assumptions about relative national capabilities and contributed significantly to declining morale among German pilots, who increasingly understood they fought at a severe and growing disadvantage that no amount of skill, courage, or tactical cleverness could fully overcome. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.